So the last topic of Unit 9 is summation notation and how to clean up. We'll evaluate and then simplify some of our sums. Now this is going to especially be helpful for those of us that take AP Calc when we do the integral by definition. So we've already done the derivative by definition. In AP Calc we do this thing called the integral, which is the antiderivative, and we also do that by definition, and that involves these things called Riemann sums. So today's learning target, our goal is to be able to evaluate and also simplify sums, and we'll know we can do it when we can properly clean things up and either get a number for a sum evaluating or a function. Let's say a formula maybe might be better for simplifying. All right, so I have this cheat sheet that you can use. You don't have to memorize all these things. You do have to be able to recognize them. So I'm looking for the sum of some variable. Now let me run through these first. I'll just talk through this fairly quickly. You have the sum of two things added or subtracted together means that you can break them apart into their own sums. So that's one move that we can do. C stands for a constant. You can take a constant and you can pull that constant out in front of a sum. And so, if you added 3 times 7 plus 3 times 8 times plus 3 times 9 plus 3 times 10, well, you could just take out the 3 and then go parentheses 7 plus 8 plus 9 plus 10. That's what this is talking about here. Then there's some quick formulas. If you want to add up the number 7 31 times, well, you could just take 7 and multiply it by 30. C stands for some constant. So some constant, however many times, would just be C times N. Now, K is not a constant. K is the number that we're plugging in. We're plugging in 1, then we're plugging in 2, then we're plugging in 3. So, for instance, if you wanted to add up all the numbers from 1 to 100, you would do 1 plus 2 plus 3 plus 4 plus 5 all the way until you get to 100. Well, someone figured out that there's a shortcut. And so you can take 100 and multiply it by 101 and divide it by 2. That actually, our boy Gauss legendarily solved this when he was in elementary school. We have a sum for k squared. Then we have a sum for the cube. So if you added up 1 plus 4 plus 9 plus 16 plus 25, and you wanted to go however many perfect squares you wanted to go, this could be the formula that would add those up. And then we have one for cubes. So the first part is we're going to talk about how to evaluate. Evaluate means that you should get a number at the end of this. You should get a specific number answer. So we're going to evaluate all the numbers from 1 to 200 of k. So now I want to look at my cheat sheet and I want to find one. Yep, okay, there it is, the sum of just k. So it's whatever this number is times that number plus 1 divided by 2. So for us, that's 200. So our formula would be 200 times 200 plus 1, which would be 201 divided by 2. Then we would grab our calc, type it in, get 20,100. Now, something that simple you wouldn't have to show your work for. You could just go to your calc right away, but the next couple ones get a little bit more complicated. So remember, you're allowed to take things, a sum of things added or subtracted, and split them into their own sums. So we don't have a formula for 4k squared plus 3, but we do have a formula for k squared. We do have a formula for a constant. We know that you can take a constant out in front of a sum, and we know that you can break apart sums. So I'm going to try to do all those moves on this one problem. So let's start by splitting them up. So they each have their own sum. So I'm going to turn this into the sum from k equals 1 to 50 of 4k squared plus the sum from k equals 1 to 50. Yes, you have to write it every time, of 3. So instead of the sum of a sum, this is the sum of two sums. Now I'm going to my goal is to try to get to one of these formulas down here. So right now this second one is good to go. That's the sum of 3. That's the same as the sum of a constant. So we've got that one set up. This other one is 4k squared. So that's this formula, but I don't want the 4 there. That's where this comes into play. You're allowed to take any constants out in front of a sum. So I'm now going to take this 4 out in front, 4 times the sum from k equals 1 to 50 of k squared plus the sum from k equals 1 to 50 of 3. Now it's just a matter of plugging and chugging things in the right spot. So 4 times, so the k squared formula, I'm looking at my cheat sheet, the k squared formula is n plus 1, 2n plus 1. I'm going to do these in my head. I'm not going to write them out the long way. So n would be 50. N plus 1 would be 51. 2n would be 100 plus 1 would be 101. All over 6 plus, and then this is the sum of a constant. The sum of a constant is just the constant times however many numbers you want to go. So for us, that would be 3 times how many numbers? 50. Grab our calc to calculate this. 171,850. You might want to try on your calculator. Make sure that you're getting these answers that I'm getting. Okay, let's see if you can try example 3 on your own. I'm going to encourage you to pause here and try this. Try number 3. All right, let's see how you did. So I'm going to do these actually in, I'm going to try to save myself a couple of moves here. I'm going to do 2 moves at once. So I notice I can break these apart. No, I'll show every step. And then I'll start to save some shortcuts down below. So this is the sum from k equals 1 to 20 of 2k cubed plus the sum from k equals 1 to 20 of 3k. Those are perfect squares, perfect squares. Those are constants, so I can take those out front. 2 times the sum from k equals 1 to 20 of k cubed plus 3 times the sum from k equals 1 to 20 of k. So now I've got a formula for k cubed. I've got a formula for k. I just got to plug in what n would be for those. So I've got the 2 out in front. I'm looking at my cheat sheet. Okay, the sum formula for cubed is n squared, n plus 1 squared. So for us, that would be 20 squared times 20 plus 1, which would be 21 squared over 4, plus 3 times, and then this is the k formula, so I'm looking at my cheat sheet again. My k formula is n plus 1 over 2. So for us, that would be 20 times 21 over 2, which then would equal, I got 88,830. All right, let's get into the tough stuff. Tough stuff is when we need to simplify. So we're going to clean this up as best we can, and hopefully at the end of this, we're going to get some sort of a formula. K is still the variable in this case. So if you look up here, K was the thing that we could leave inside, but we could take out any constants. Well, N is some number. We just don't know what our number goes up to. So N is some number. So that you can treat N as a constant and K is your variable. So right off the bat, I noticed that I can do I'm going to do one at a time on this one. So I've got a constant. This N squared is a constant, but it's on the bottom. So when I pull it out, it's going to be 1 over N squared times the sum of, from K to 1 to N, of 3K plus 2. So all I did was take out that constant piece. Now, what can I do with these two? Well, I can split them up. But when I split them up, you got to be careful because that 1 over N squared is going to be in front of each of them. So I'm going to write 1 over N squared, and then I'm going to parenthesize at this point the sum from K equals 1 to N of 3K plus the sum from K equals 1 to N of 2. And again, I've got a constant here, so I can now take that constant out. So I have 1 over N squared times the quantity 3 times the sum 1 to N of K plus the sum from 1 to N of 2. So we can't do any more cleanup here. Now we're going to substitute. So in this case, the sum of K We have a formula for that. The sum of k is n plus 1 over 2. So I'm going to take out the sum of the sum of k, and I'm going to replace it with this formula. So I would have 1 over n squared times the quantity of 3 times, and now I'm going to replace that with my formula. From the cheat sheet said that the sum of k was n plus 1 over 2 plus, and I've got the sum of 2. That's a constant, so that's 2 times n. So for us, that would be 2n. Now it's just a matter of trying to get this thing cleaned up. So let's try to, I'm going to do a couple of things here. I'm going to distribute, remember, I'm going to take this 3. This is over 1. I'm going to take the 3, I'm going to attach it to the n. That's 3n, and then I'm going to distribute it. And at the same time, I'm going to distribute this to my denominators, which I don't have a denominator for this one. I'm going to make it when I put it in there. So let's see. What's 3n times n? That's 3n squared. What's 3n times 1? That's 3n. Over what's n squared times 2? That's 2n squared. Plus what's 2n divided by n squared? 2n over n squared. Now, from here, you're going to think, hey, I can cancel. Yeah, you can. You could also cancel here. My advice is don't reduce anything until the very end. And the reason I say that is because I'm going to try to get a common denominator. So if I want to get a common denominator, I'm going to leave it as it is. Unless it's super obvious to clean it up, I'm not going to. So I'm going to also be a little lazy here. If I want this to be a 2, I'd need to change that to a 4. So now I've got a common denominator. My common denominator is 2n squared. And then let's see, we have some like terms on the top. So I've got a 3n squared plus 3n plus 4n is 7n. And then now I can reduce some stuff. So everything has an n. Nothing goes into 3, 7, and 2. So I'm going to leave the coefficients as they are, but I can reduce 1n. So 3n plus 7 all over 2n. Now what this thing does is now we have a formula. The point of this, you now have a formula for this sum. So whatever sum, if you want to go to, let's say, 77, from 1 to 77, well, now you can just plug 77 into these two things and evaluate like you would have done up here. That's the whole point of this. You're trying to take something that's super crazy and trying to make it something halfway decent. All right, this one's a doozy. This one's a real doozy. So there's lots of ways that you can attack this. I always start off by trying to take out any constants. That to me is the obvious choice. So if I look at this thing, I've got a constant of 2 over n. So these have some constants, but I can't take anything out because those three, there's nothing that's common between all three of them. But this is multiplied by the whole group, which means I can take that whole section out front. So that's what I'm going to start off with. So 2 over n times the quantity. And now this is what I was talking about earlier about doing a little bit of shortcuts. I'm going to also split this up at the same time because each one of these can get their own sums. So that's going to become the sum. Oh, no. Let's really try to save ourselves some time here. So I took this constant out front. Now I'm going to split these up. But these two have constants. So I'm going to take those out of their spot as well. So this is just the sum of 2. From k equals 1 to n of 2 plus. Now, what do you notice? This has a constant of 1 over n. So in front of that piece, I'm going to take out a 1 over n. From 1 to n of, if I take out the, no, dang it. You know what I should have taken out? I should take out the 3 and the n at the same time. Let's do that. So I took out the 3 and the n. That's all constants. And then what does that leave behind? K squared. You see how nice that is? Now k squared is one of our formulas. Plus, Then I look at this section. What are the constants? What can I take out? I've got an n squared on the bottom, that's a constant, but I've got a 2 on the top, that's also a constant. So I can take out the 2 and the n squared out of this sum. And what does that leave behind? From from k equals 1 to n of k cubed, which I have a formula for on my cheat sheet. Equals, okay, so we've still got our 2 over n out front, times the quantity. Okay, this is the sum. This is one that we can figure out. The sum of 2n times would be simply 2n. Plus 3 over n times. Now we've got this formula for k squared, which I'm going to look at my cheat sheet. There's the formula for k squared. And we can't plug anything in for n besides leaving it as n. So it would be n plus 1, 2n plus 1 over 6. Plus, see if you can do this. Pause and try to do this last one on your own. Okay, so I've got my 2 over n squared. That's already with me from the previous line. Now I'm going to sub out this sum and put in what its formula is instead, which would be n squared, n plus 1 squared over 4. Now I need to close my parenthesis because all of that's getting multiplied by 2n. All right, well, you did the heavy lifting if you got to this spot. The rest of this is now just algebra. So now I'm going to start to clean some things up. I'm going to try to distribute as best I can while I'm going through. So I'm going to distribute 2n, 2 over n to 2n. I know stuff could cancel, but like I said, I'm going to cancel at the end. I'm going to reduce at the end. So I would get 4n over n plus, okay, so this is worth expanding once and then never doing it again and trying to see if there's a pattern. So the pattern here is I'm going to distribute these two binomials first and then distribute the n after that. So that would look something like n times, let's do n plus 1 times n 2n plus 1 would be 2n squared. N plus 2n would be 3n. 1 times 1 is 1. Now I can take this n and distribute that through, so I would get 2n cubed plus 3n squared plus n. Now that margin work I'm going to bring back over here because that's what this numerator is, but what is that getting times by? That's all getting times by 3. So I want to make sure that I multiply all of that. Oh, sorry, 6. Where am I getting 6? Because this is 2 times 3 times this. So 2 times 3 is 6. 6 times 2n cubed is 12n cubed. 2 times 3 is 6 times 3 is 18n squared. 6 times n is 3n all over. N times 6 is 6n squared. Plus, okay, now I'm going to do the same thing here. I've got to expand this first. If you can't do it in your head, which I can't either, I'm going to go to the margin and I'm going to write myself a little note so that I can use that note to help me figure it out. So I'm going to do n squared. And what's n plus 1 squared mean? It means n plus 1 and n plus 1. So that's n squared times n is n squared, plus n is 2n plus 1. Then I'm going to distribute again, n to the 4th plus 2n to the 3rd plus n squared. So that's what the expansion of this looks like. And if we were doing a lot more of this, I would tell you to memorize those. It's probably worthwhile to it's probably easier to just expand them instead of trying to memorize them. So this is getting multiplied by 2 times 2, which is 4 times that. So that would be 4n to the 4th. 4 times 2 is 8n cubed. 4 times n squared is 4n squared over n times n squared is n cubed times 4 is 4n cubed. Whew! Good old-fashioned algebra. So from here, I want to get a common denom. So I want to try to get all these denominators to be the same thing. What's the least common multiple of all of these? I guess I could shoot for a 12, maybe, or a 24. I mean, sometimes you could think about this in terms of how many, just multiplying everything by each other. That's a guaranteed way to get a common denominator. I'm going to go for 12, though, because 4 can turn into a 12 and 6 can turn into a 12. So if I need to multiply this by a 12, and what's the least number of n's? I need 3 n's. So I need to multiply. I'm going to times this one by, I'm just going to write it over the top. I'm going to times by 12n squared. So this would become 48n squared over 12n cubed. No, 48n cubed, because we're timesing by n squared. 48n cubed over 12n cubed. Now I'm going to times this. Sometimes it's helpful to just draw a line through there. I need to times this by 2 and then another n. So 2n. I'm running out. I can't see it. Sorry, I'm going to have to rewrite it. So this will turn out to be 48n cubed over 12n cubed plus. This needs a 2 and another n, so this would be 24 n to the 4th plus 36 n to the 3rd plus 12 n to the 2nd over 12n cubed plus this just needs a 3 because I've got the n cubed, so I need to times by 3. 12n to the 4th plus 24n cubed plus 12n squared over 12n cubed. And I was hoping to write my answer in that space, but I'm going to have to write it down here. So let's see, how many to the 4ths do we have? 24 plus 12. I'm going to cross these out so I can keep track of them. 24 plus 12 is 36 n to the 4ths. Plus how many n cubes? 48 and 36 and 24. I need my calc for that one. 48 plus 36 plus 24 is 108. N cubes plus 12 and 12 is 24 n squareds over our common denominator of 12n cubed. The key, last but not least, is to cancel out stuff here. Is 108 divided by 12? I think so. Nope. Yes. So everything's divisible by 12. So I'm going to divide everything by 12, and I'm going to kill off, looks like I can kill off 2 n's. So divide by 12, that would leave me with 3. Kill off 2 n's, 3n squared. 108 divided by 12 is 9. Kill off 2 n's, that leaves me with 1 n. 24 divided by 12 is 2. Kill off 2 n's, there are none. 12 divided by 12 is 1. Divide by 2 n's. There's the formula. All right, just to point out again, there's a big difference between evaluating. Evaluating is a dream come true. You just basically type it in and go. You know what I mean? Just formulas from there. But evaluating leads you into the tougher part, which is simplifying. There's a couple on the last couple ones on the homework. I really recommend. Those are going to be the tough ones. So don't blow off those last ones with the constants that are n's. Those are the ones that you're going to need a lot of practice on.